So today we're doing graphs to equations. Just a heads up. On all of these graphs, you are able to make multiple equations from them. For the first two examples, just to kind of ease our way into it, we're only going to do one equation each, and then the backside we'll do two. On your homework and on the test, you'll be asked to make two equations, one for sine and one for cosine. But let's just go over the basics for these first two. For our first graph, and you may want to consider something colorful for these graphs, so I'm going to be doing two different colors on the graph. Whether that be a highlighter, a marker, a colored pencil, a colored pen, just something. That's going to more so come into play when we get to the back side. So the most obvious place to start on the graph, of course, is the origin. So this is where I'm going to start my first graph. Now that first curve going to the right from that circle, is this a sine or a cosine curve? This is a sine curve. So we could see that S shape. I'm going to highlight one full curve, one full S curve. Again, we have an S curve here. So we're going to be working with the sine function here. General form of the equation. It is different from the other notes we've done. Not entirely, but there are a couple of details that are going to change. First off, we don't just put A, we put plus or minus A. You have to be well aware of the fact that your A is either positive or negative. That is a decision you have to make sure you're making. Don't just blindly write A and not think about what sign it has. Sine. Here's the biggest difference between the previous equation and this one. B is outside of the parentheses this time. X. For these problems, we don't use C and D. We use phase shift and vertical shift. So it's X minus PS for phase shift plus VS vertical shift at the end. Below that, I'm going to set up kind of the template, the outline of what my equation is going to look like. Y equals, leave a blank for the A. Sine, blank for the B. X minus is part of the general form. Blank for the phase shift, plus a blank for the vertical shift. We have to find these four pieces of information before we're able to finalize our equation. I'm going to leave a little bit of space under here to write the final equation because there are going to be some ways to make it look a little nicer. So under that line is going to be my workspace. If you'd like, on your own, you could do the normal list of information. That is one way to go about the problem. To some degree, I am going to find all of that stuff. I just won't put it in a list format. So that's up to you guys. First thing I'm going to find is the amplitude. If we work left to right in that equation, we'll first find the amplitude. Let's go back up to our graph. The max is at 1. The min is at -1. So to identify the amplitude, we first need to identify the midline, the middle of the graph, which if we're sitting on the origin, the midline is the x-axis. So hasn't been shifted anywhere yet. For emphasis, I'll draw in the midline on this one. From there, the amplitude, we go up 1 and down 1, so it's just 1 for this equation. Our A value here is 1. And then we have to decide if it's positive or negative. That goes based on the way the curve is moving. So looking at our curve here, and I'm going to steal from the other day's notes, the sine curve with a reflection versus without a reflection versus with a reflection. If it goes up, it's positive. If it goes down, it's negative, reflection. This curve is going up like it's supposed to. There is no reflection here. This is a positive one. So I'll add for clarity down here, no reflection. Next we find B. B takes the most work out of anything. Now there is a formula you're going to have to use here. Period equals 2 pi over B. And reminder, the period is the length of one curve. So if we look back at our graph, this is why we highlighted the curve at the beginning. It actually has a dual purpose. It makes it easier to identify the period later on in the problem. So we go from 0 to 2 pi. Clearly our period for this problem is 2 pi, the standard period. So the period of this specific problem is 2 pi. Let's use the formula. Again, its period equals 2 pi over B. We now know that the period is actually just 2 pi. So 2 pi equals 2 pi over B. There are a couple ways to go about solving this for B. I am going to show you the way we're going to use it every time. This one's a very simple problem, but further on we're going to see some more complicated ones. So the most straightforward way to solve these is by cross multiplying. You have to have fractions on both sides in order to make that work. Those of you who kind of already see where this is going, yes, B is going to be 1. This would be a very easy case to notice that, but just to show you how the work is going to go, I'm going to work it out. Cross multiplying. Make sure when you do this, you actually get an equation when you're done. So I always go left on the left side. So 2x times b. And if it helps you for your process to literally write 2x times b, do that. Equals 2 pi times 1, that's just 2 pi. As I said, make sure you get an equation. I have students who will just stack them like another fraction and go from there. That's not going to work. Make sure it's an equation. To solve for b, we just need to divide off the 2 pi on both sides. These are going to cancel on the left. B equals, clearly this is just going to be 1. B is 1. So I'll come up here and fill that in where it goes. Don't assume B is going to be 1 every time. That is rare. Lastly, we need to figure out phase shift and vertical shift. These are very easy to identify and they're pretty visual. You just look at the graph and look for them. Let's go back to our starting point. We're at the origin. If you're at the origin, that means there is absolutely no phase shift, left or right, up or down. We're starting where we're supposed to. So in this problem, they're both going to be 0. At the bottom, just for notes purposes, I'll just add No PS or VS. No phase shift or vertical shift here. This is an okay answer to have. There's nothing wrong with it. It's just we've got a lot of extra stuff in there that we can drop. So I'm going to write a better version of the equation. We don't need a 1 out in front, so I'm just going to start with sine. B is 1, so we don't have to write it. And then clearly we can drop the zeros. So this was actually the plain sine curve, completely untouched. This is the process with a very simple graph. Any questions on the process before we do a slightly more difficult example? Okay, next problem number 2. I'll go ahead and tell you now this is not going to be y equals cosine of x. For those of you already thinking that's where this is going, it's not. If we start at the origin, you can see this time we're starting at a maximum, and that's going to create a cosine curve, the u curve. Let's go ahead and outline one full u. It goes from maximum to maximum. Again, this is a u curve. So that means we have a cosine function. I'll write the general form. It'll look the exact same as with the sine, except it'll have cosine. Y is equal to plus or minus a cosine of b. In parentheses, we have x minus the phase shift plus the vertical shift on the outside. I'll go ahead and set up my starter equation under that. Y equals, we'll figure out a cosine blank for b, x minus blank for phase shift, plus blank for vertical shift. And then just like before, I'll leave a little bit of space. To write my final equation, and then some work underneath. I'm just going to go in order from left to right, but you can honestly go about filling this in pretty much any order that you want to. First things first, let's find the amplitude. We're on the origin again, and just like before, we're only going up to +1 and -1. -1 the min, max is 1. So just like before, the amplitude is 1. Once again, the midline is the x-axis. So our amplitude is 1. And we're starting high instead of low, so we're starting at a positive, not a reflection. So once again, this is a +1 for our A. No reflection. Next, we'll find B. Our formula is period equals 2 pi over B. Going back up to the graph, again, this is why we highlight an entire curve. We go from 0 to 3 pi over 2. 3 pi over 2 is the period. Equals 2 pi over B. From here, we cross multiply. Crossing the left side, we have 3 pi times b. equals 2 times 2 pi will give me 4 pi. And to get the b by itself, we'll divide off the 3 pi on both sides. This will cancel on the left. B equals, what does that simplify to? 4/3. The pi's will cancel each other out. So we're left with just 4/3. On these problems, we will be seeing some interesting b values. Lastly, phase shift and vertical shift. Once again, we're starting at the origin. There is no shift left or right. So we have zeros in both of those spots for this one as well. Yes?
How are you supposed to know if it's a sine or a cosine that's like they're just adjusted a lot?
What do you mean that's been adjusted a lot?
Like, once you're on the back, if you're looking at that, how do you know like where which one it starts at?
Yes, so that's where it depends on where your starting point is. So to answer your question, we can actually make a sine or a cosine equation depending on where you start on the graph. That's where I'm going next. Yes. Once again, I'm going to make a note at the bottom about how we don't have a phase shift or vertical shift here. And that's because we're at the origin. Again, let's clean this up a little bit. Y equals, we can drop the positive 1 in front. Cosine of 4/3. X in parentheses, the zeros can be dropped as well. This is our equation. Questions on the process before we do an even more difficult problem? Okay, so those were essentially a warm-up. Let's look at number 3 on the back. Now this is one where having 2 different colors may be beneficial. I'm going to use 2 different colors here. Or at the very least, if you use like a pen or a pencil, something like that. So, where you start, completely up to you. Most of us still graduate to the origin area. Now, obviously, we can't start on the origin because the entire graph is above that. So, let's go up and meet where the line does cross the y-axis. This is going to be my first starting point. From that point, if I follow the curve, you can see I have a sine curve. So let's go ahead and trace that. In doing this, I've already kind of identified where the midline is, where the middle of the points are at. It's going to be at that too, which is our, also kind of spoiling this, but our vertical shift. All of these things kind of connect together. Now our midline is not the x-axis, it's through 2 on the y-axis. Sine is the first curve that naturally came out of this graph, so that's the one I'm going to start with. Reminder, on this problem, I'm going to find a sine and a cosine, just like you'll do on your homework and on your test. I'm not going to write the general equation out, I'll just set up the template I'll need. Y equals a blank for A, sine, a blank for B, X minus a blank for the phase shift, plus a blank for the vertical shift. I'm going to leave some space for the final version of the equation, and then I'll do the same thing for cosine. Y equals, we'll find A, cosine of b x minus whatever the phase shift is plus whatever the vertical shift is. And then some space for work below. I'm not going to show a lot of work on this one. First thing we'll do is find the A value, the amplitude. So we found our midline. From there, our maximum is 4. So from the midline up to the max, we go up 2. So our amplitude here is 2. So our A value is 2. And from the starting point, we go up. That's positive. No reflection here, so this is a positive 2. Next, the B value. I'm going to come down here for that. We need our formula, period, is equal to 2 pi over b. And let me go back up to the graph to see what the period is. Going from 0 to 4 pi, so 4 pi in length. We have 4 pi is equal to 2 pi over b. I'll put the 4 pi over 1 for the cross multiplying. Crossing left, we have 4 pi times b equals 2 pi times 1. Well, that's 2 pi. Divide off the 4 pi on both sides. B equals, the pi's are going to cancel, and the 2/4 reduces to 1/2. This time B is just a half. Fill that in above. Now we're just down to the phase shift and vertical shift. So our starting point here, clearly it has moved up 2 from the origin. So my vertical shift is plus 2. I'm just going to put a 2 there. And I haven't moved left or right, so this is still 0 for the phase shift. Going to clean that up a little bit. Y equals, I'll just put 2 sine of a half x, I'll drop the 0, plus 2 at the end. That's my sine equation. Once you make an equation, making others is less work because you've already found most of the information. Yes?
My B, I got 2.
You got 2 for B?
Yeah.
Okay. Did you cross multiply or did you do something else?
I cross multiplied 2 pi over b equals 4 pi over 1.
Huh?
And then
And then, oh, you needed to divide by 4 pi instead of 2 pi on both sides.
that's probably it.
Yep. You're welcome. Cosine equation. Let's look at this graph and identify a cosine curve. There are plenty to choose from. There is no right or wrong answer here. Whichever curve you choose is just going to give you a slightly different equation. Now, I already have one picked out, but you can go and give me your 7 if you want.
Pi 4.
Which one?
Pi 4.
Pi 4.
Yeah, equals pi 4.
Oh, are you talking here?
No. Pi 4. So, pi 4.
Yes. Okay. So Devin pointed out starting here, which is the most convenient place to start. So you can start there if you'd like. My only thing is I don't want to overlap my colors on this one. So I'm not going to pick that one this time, but if it were me just doing it just to do the problem, that's the one I would choose. So just for neatness sakes, I'm going to come all the way over here and start here for my U-shaped curve. So my starting point is going to be at 5 pi. And again, there are several answers to these graphs. So it doesn't matter which one you pick as long as your equation is correct for what you chose. Since I moved the starting point to the right, clearly I have a phase shift now. So I have a phase shift of x equals 5 pi. And now I can finish my equation. So here's the convenient thing. A and B don't change. They are the same for the entire graph. So it's positive 2 in the front. B is still a half. And the vertical shift can't change either. That affects the entire graph. So it's still plus 2 at the end. So the only thing we're changing is the function, the phase shift. So I went to the right, 5 pi. I kept that minus there for a reason. So it's going to look like x minus 5 pi. And also a side note, something you'll have to pay attention to is the reflection. The other thing that can change from equation to equation is whether or not the a is negative. In this case, this is a normal U-shaped cosine curve, so there is no reflection. I'll show you what a reflection looks like in the next example. This is our equation, and honestly it looks pretty good. The only thing I would drop is the positive in the front, so I'm going to leave it like this. One thing I'd like to point out in case there's any confusion around this. With the phase shift, in here it's always the opposite sign from how it looks. So we know that this is actually a positive 5 pi, that's what I did, but when it goes in the equation it looks negative. And the reason for this is because if I wanted to find this by hand, I would set that equal to 0. And then when I solve, I get x equals 5 pi, which is what I had to begin with. I make a big deal about that because hands down when it came to this problem on the test, that was the most missed detail, was not putting the correct sign there. So make sure you're extra careful with that.